High-quality, handmade furniture often contains intrinsic joints that connect parts using interlocking geometry. These joints are valued for their structural integrity and aesthetic beauty. But designing the 3D geometry of the joints so that they assemble and interlock can be challenging. Even joints with relatively simple surface regions can have surprisingly complex internal geometries. We present a tool for designing decorative joints. Given a solid 3D model, users paint its surface with a color for each part in a tool like SketchUp. We call these surface 2D parts, and users can easily design the visual aesthetics of joints. Our tool automatically generates a set of solid 3D parts suitable for fabrication that conform to the surface 2D parts and guarantee assembly into the solid model. Our tool takes user-drawn surface 2D parts as input. Each such part is a partial surface shell and does not yet include any volume. The user presses a button to apply our algorithm for constructing solid 3D parts. Our algorithm first tries to find a collision-free disassembly sequence for the surface 2D parts using only simple translations. If it cannot find such a sequence, our tool visualizes the disassembly sequence with the least collision area between surface parts. Here, our tool highlights the collision regions between the green leg and purple tabletop. Users can quickly resolve the collision either by giving the entire collision region to the green leg or by giving the entire collision region to the purple tabletop. The resulting pair of surface 2D parts are now guaranteed to be collision-free. Alternatively, the user can resolve collisions by repainting the surface in SketchUp. After resolving all such collisions, our tool constructs solid 3D parts that assemble into the furniture and conform to the user's 2D surface specification. Our tool also checks if solid 3D parts are stable in their assembled configuration under external forces such as gravity. This analysis reports that 3 of the legs can slide with respect to the tabletop. For unstable configurations, our tool suggests where users can alter surface regions to improve stability. Adding a leg region within the yellow highlighted area will fix these instabilities. The user redesigns the legs based on these suggestions in SketchUp. And returns to our tool to generate new, stable, solid 3D parts. We have validated our tool by designing over 100 decorative joints, just by drawing the visible surface. Some are based on classic woodworking joints, while others are based on complex Japanese joinery. We have also designed a variety of decorative joints from scratch. We have used our tool to produce a number of structurally sound furniture models with decorative joints.